All right. The last two problems that we're going to do are going to be slightly similar to each other, but they're going to be a little bit different from what we've done previously. They're going to relate, okay, area and perimeter, and you are looking for a largest value, which means you're looking for a maximum value. Okay, we're going to start off with this more basic one, and then we'll move on to the more difficult one. Okay. You have a 500-foot roll of fencing and a large field. Okay, so a 500 roll of fencing means that you have a perimeter of 500 feet. So writing that down, we know that perimeter is 500 feet. Now, if you remember correctly, perimeter means the length around. So 2 times the length, 2 times the width added together. All right. You want to construct a rectangular playground area. What are the dimensions of the largest such yard? What is the largest area? So what we're looking to do is we're looking to maximize area. Okay, now if you remember, area is length times width. But that would give us too many variables. Okay, we want to get it down to 2. So what we're going to do is we're going to take our perimeter and use that to solve for one of our variables and substitute. So what I'm going to do is I'm going to use my 500 feet. Oops. And I'm going to solve for L. Okay. So I'm going to subtract 2W. I'm going to divide by 2. Like that. Okay, so now my area formula could read area is equal to 250 minus W times W. So I have a length times a width still. Okay, so this is going to give me a quadratic. So if I distribute that W, I get 250 W minus W squared. Okay, that's a little bit backwards from what we're used to. So area is equal to negative W squared plus 250 times W. Okay, now I want to know maximum area. Okay, now if I'm ever looking for maximum or a minimum, I know I'm looking for a vertex. Okay, by looking at this particular quadratic, I know that that parabola will open down because of that negative A value in the front. Okay, so this parabola will have a maximum. So let's find it. So I'm going to use the formula x is equal to negative b over 2a. So that gives me negative 250 divided by 2 times the negative 1, which gives me 125. Okay, now that's a width. Okay, now if I take that value and use it to find the y value or the area, that's actually going to give me the maximum area I can achieve. So area, negative 125 squared plus 250 times 125 Okay, so my maximum area would be 15,625 feet squared. That would provide me the maximum area. The dimensions of this would be a width of 125 and a length, going back here, 250 minus 125 of 125 feet. Now, if you're sitting there going, well, if I have a yard with dimensions of 125 by 125, isn't that a square? You'd be exactly right. Remember, a square is also a rectangle. Even though they use the word rectangle, it doesn't have to look like your traditional rectangle where the height is longer than the width. A rectangle is also a square. Okay, so it just so happens that squares will always give you a maximum areas. Okay, let's go ahead and do the second one. All right, this time we have 1,200 foot roll of fencing and a large field. We want to make 2 paddocks by splitting the rectangular enclosure in half. What are the dimensions of the largest such enclosure? Okay, this one's a little bit different. Okay, so our perimeter, okay, that's 1,200, which is the amount of feet that we're going to use for fencing. However, we got this divider in the middle. Okay, so let's say that this is the width, and these two guys are the length. Okay, so the actual perimeter of the outside of our fence, okay, is going to be 1,200 2W plus 2L. Okay, so this is the outside. All right, plus the middle, right? So this makes it a little bit more complicated. All right. So do we count that middle when we calculate the area of our enclosure? No, we don't. Okay, so the area of our enclosure is still length times width. Okay. But this is going to make it a little bit interesting. All right, so here we go. We need to get rid of a variable. So let's see. Let's solve for W this time. So if I simplify my perimeter formula, I get 3W plus 2L. And if I solve for W, that gives me 1,200 minus 2L is equal to 3W. Now I'm going to divide by 3. So I get 400 minus 2/3 times the length is equal to W. Okay. So now what I'm going to do is I'm going to substitute that into my area formula and try to find a maximum. Now another way to find a maximum, if you don't want to use the formula, you can always go to Desmos and use Desmos. But sometimes Desmos is wonderful, but what happens with Desmos is that sometimes you can spend so much time messing around with the window to get it look how you want it to look. it sort of kind of makes things more difficult. Okay, so let's distribute our L. So we get area is equal to 400L minus 2/3 L squared. So again, you can go to Desmos, find the maximum area that way, or we're going to use our friend x equals negative b over 2a. Now again, this is written backwards, so it's going to be negative 2/3 L squared plus 400L, like that. So negative 400, okay, 2 times the negative 2/3. I'm going to put that in my calculator and see what that is. That would be 300. Okay, so now I know that my x value, or the length, has a vertex at 300 feet. Okay, I can also figure out the maximum area by using that 300. So let's go ahead and plug that in. So I get 60,000 square feet. All right, so now let's go ahead and find the rest of the dimensions. So I have a 300-foot length, a 60,000 square foot area, and then so my width would be 400 minus 2/3 L. L is 300. So $200. So if I have 1,200 feet of fencing, this is going to be 200. This is going to be 200. This is going to be 200. And then this right here would be 300, 300. Okay, so let's make sure I have 1,200. 3 and 3 is 6. 2 and 2 and 2 is 6, so that is 1,200. And if I multiply the 200 by the 300, I get 60,000 square feet. Okay, notice that this did not result in a perfect square because of that divider in the middle. Okay, so we have a 20, or excuse me, not 20, 200 by 300 foot enclosure with a perimeter of 1,200 feet and with divider, excuse me, and an area of 60,000 feet squared. Okay, again, you can use Desmos to graph these if you wish, but sometimes it is a little bit quicker to use your formulas. Okay, I hope that helps you, and we'll see how this goes. All right, thank you.